Hello, my dear electrical professionals. कैसे हो? Today we'll discuss on introduction to substation design. In previous class, we have overly explained the power system, different components of power system. And as I have told in the previous class that the substation is the core part of the power system and is the most critical part of the power system. So today we'll discuss a focus on that and we'll give some introductory basics of the substations. In this substation design, slowly and gradually we'll go to the depth, but in preliminary classes I will give the overall idea regarding the different steps and parameters for substation design. So you know what is the basic definition of the substation. The basic definition of the substation is it is an electrical substation is the critical part of a electrical power system. It is the critical part of the electrical power system. And where the voltage is transformed and power is controlled and the electricity is distributed to different consumers safely and efficiently. It does so by using the transformers, switchgear and protection system. So the main components of the substations, the transformer, switchgear and protection systems. These are the critical parts of the substation. An introduction to the substation design gives us the structure understanding of how electrical power is received in substation, how we will study how power is received and transformed, whether step up and step down, controlled and protected against different type of faults in which the part of the power system is isolated automatically and distributed safely, and at last it is distributed safely and efficiently to its end consumers or end users or end consumers. So there are different types of substations. A step-up substation, usually it is located near the generating station or power plant, but the power is generated. There is a step-up transformer. We know the voltage is generated at 11 kV to 25 kV. Here it is step up to higher voltages. Higher voltage it may be 132 or it may be 220 or it may be 400, like that. And step down substation where those may be 132, suppose in long transmission line carrying 132 kV in 132 kV power, and this it is step down here, and switching substation where the switching substation is located at intermediate substations. Switching substation only this type of substation have no transformer. There is no question of step up, step down. Automatically it is transferred to the switching substation. It is operated and as a switching station only through isolators and circuit breakers. Then distribution substation. These substations are the last stage of the before consumer's end, where the power is distributed. It may be at 11 kV or 33 kV, like that. On the basis of the installation, this is the classification of the transformer on the basis of functionality, and we may categorize the substation classification of substation on the basis of the installation. It may be outdoor substation, air insulated, AIS air insulated substation, indoor substation, GIS substation, gas insulated substation, or pole mounted substation, which is used at local area at consumer end. The primary equipments of the substation is your power transformer, then circuit breakers, and isolator. Here are the isolators and current transformers. These are the current transformer, potential transformer. These are the potential transformer, and lightning arrestor. Here is the lightning arrestor, which is immediately earthing fault current. Huge amount of fault current goes to the earth through lightning arrestor. Then the bus bar. These are the bus bars. The incomers are connected to the bus bar, incomer bus bar. So these are the primary components or equipments of the substation. Then as a secondary system, there is a protective system, protection relays. The relays are installed for protection purpose. Similarly, these are called the control panels, and SCADA system and metering. The SCADA system will remotely control the parameters of the substations. Then apart from secondary system, there is a support system for the substation. One of the important part of the support system is your earthing system. Where these are the earthing grid is there. Earth feeds are there, and this is the road, earthing road goes to the soil in depth. This form a mesh, and the equipments are connected to that. So this is earthing system. Similarly, battery chargers. These are the battery chargers. Battery bank is there. When the power is failed, when power fails, then it is automatically the protective release and protective system would get power from this battery charger in order to operate the protective, to keep the protective system operating. Apart from that, there is a fire protection system. Fire protection system automatically where there is a firing short circuit or fire due to any hazards, fire hazards inside the substations, automatically it is operated. And toward the substation, cable in and out cables are is at the cable trench. Through the cable trench, cable are coming to the substation and going out the substation in different ways. So these things will, in course of time, these things will be discussed more deeply and on calculation basics. So as this is the preliminary class, I am giving only the preliminary idea, and gradually we will go to discussion of each of the component of the power system thoroughly to know details, what are the design criteria, how to maintain that, how to select different parameters perfectly, these things. Then basics of substation layout, how the equipments are laid on the substation in different ways. First, in carving 30, suppose a case of 33 is this figure for 33 kV 33 by 11 kV substation. When in comer 33 kV is coming, 33 kV feeder bay, and there is a transformer bay where the voltage is transferred. Then 11 kV after this it is transformed at feeder voltage at 11 kV outgoing feeder panel, then control room, then your earthing grid, lower level it is earthing grid. So this bus bar system, the substation may have common bus bar schemes. It may be single bus or maybe double bus, single bus or single bus with a sectionizer. That means one bus is in two sections. Through these two sections there is also isolation here, isolated. Two sections are isolated. Similar double bus and ring bus and breaker and half scheme. This is applicable only ESP substation. Our main discussion is on that only. While going for the design of the substation, first we take the input parameters, load demand calculation, present and future. For the present, what should be the connected load, and for future expansion, what will be the load. Then taking the load demand in consideration, we take the what type of voltage we select. Similarly, short circuit level calculations protection coordination. So the short circuit level calculation for protection coordination. For protective system, we have to calculate what are the short circuit current. What will be the short circuit current? Then these are the calculation design part. Then physical part, the equipment spacing, how the equipment will be spacing as per standard. That means there must be some spacing between equipments as per standard, and clearance, phase-to-phase clearance must be maintained, which is also a standard, and phase to earth should be maintained, and layout of optimization, that means the equipments will be laid in a specified area perfectly, obeying every parameter, obeying every design criteria, spacings and clearances. What will be the layout, the optimization layout for optimization. Then design considerations for earthing system. Earthing system is the most vital part of the power system. It's very critical. We have to calculate before designing the earthing system, we have to calculate all its earth resistance, resistivity. According to the earthing calculations are there. When we'll study it in detail in next classes. Then lightning protection, in this lightning protection, during the lightning, the source voltage, how it will be readily absorbed by the earth, by the earthing system. Safe protection zone, there is a safe protection zone. Reliability and redundancies of one equipment is failed means there is a standby equipment. N1 criteria system should be survive with failure, and duplicate feeders and transformer. There must be standby feeders and or transformers during the major failure. As the earthing system is very critical, we will know some more about it. It is the most critical part of the substation. While taking the design part, we have to consider the personal safety, equipment protection, and fault current dissipation. How much fault current can be dissipated through the earth? And equipment protection, we have to consider how the equipments will be protected. Side by side, how personal safety can be maintained. During the calculation, what are the touch voltage, step voltage, these things will be calculated. So earthing system consists of earth grid, GI flat or copper flat. These are things. GI flat, this is copper or GI. Similarly, earth bits, equipment earthing. Equipments are connected to the earthing, to the earth flats. Neutral earthing, transformer or neutral is connected to the earth. The neutral earthing is also very vital part for the power transformer or distribution transformer. discuss about the protection system overview, something about protection system. The protection system is designed to detect the fault instantly. The fault should be detected instantly, and the system or the part of the power system should be isolated. The faulty part should be immediately isolated from the normal running part, avoiding the major breakdown. The common protections are overcurrent protection. When current is immediately reached or go to the normal value, above the normal value, automatically the relay operates and circuit breaker isolates this system. Differential protection, it is the protection for the transformer, differential protection. Similarly, distance protection, it is employed for transmission line. Whatever the during the system when the earth fault is there, any conductor or phase is connected to the earth, then immediately the relay will be operated and the system will be isolated. During the design criteria, we will consider the Indian standards, IS, IEC standard, and Central Electric Authority guidelines for India, and utility specific such as OPTCL, PGCL or utility based standards. Also, other standards are there, international standard, IEEE is there. All these standards will be followed during design of a substation. When we design the substation, we follow the criteria. First, substation design workflow. We have to understand what are the requirements of the client, and accordingly we make the data for specification and preliminary study. Then single line diagram development, we will prepare a single line diagram. Then HB equipment layout, that will be the layout drawing for the equipments, and detailed design calculations, all these parameters of the substation, detailed drawings and bill of materials. Then after that we'll make the detailed drawings and bill of materials. Then after that we'll submit to the client for approval. After it is approved, it will be carried out or executed, construction and implementation. As soon as the construction is completed, we'll go for testing and commissioning. The substation is at last charged and it is taken into operation through our system. So these are the load calculation has to be very, this is the overall, I have already told what is the workflow, main workflow, and during the workflow the load calculation with load study and system planning, selection of voltage level, single line diagram, I have already told, equipment selection and rating, how to select the equipments and rate it, and layout design, earthing design, as per the equipments and requirements we will design the earthing, the protection scheme design, what will be the protection scheme, we will design that. Then at last bill of quantity and cost estimation, we will make the cost estimation and bill of quantity. So these are the basics for introduction to the substation design. In later classes, we'll go for detailed study of the design parameters, design calculations, design of earthing, design for protection system, protection coordination. All these things, the calculations involved with this will go in depth in course of time. Today, this much only. We'll see again in the next class. Thank you.